Group 9, and our project is called MOCOID 2.0 Spherical Hologram. So our goal was to merge the MOCOID from assignment 3 with a concept called persistence of vision, or POV, which is when the human continues to perceive an object or image for some time after the object or image disappears and the light rays stop entering the eye. And for the human eye, this is obviously not very long before the brain realizes that there's no object or image there, and it's about 1/16 of a second. So the simplest example of this is just waving an object back and forth really fast so that it appears to be in more than one place at once. And this was something that we also observed in the first class of this course, I believe, with the SWIM demonstrations. So persistence of vision is also a fundamental principle in animation. So this is flipbooks, which you've probably seen before, which are still images just being displayed in quick succession to the point where it looks like there's movement. So we, in our design, played around with this concept and expanded on the MOCOID, where long exposure images were required in order to see a full image. And by increasing the speed of the motor and improving the resolution, we were able to come up with some cool stuff, so we will show you that in a bit.
So the hardware is all connected to Arduino Nano on top. We have a slip ring that allows the Arduino wires to connect to a rotating LED, and we get the positional data of a Hall effect sensor, and we put all of this on a proto board on top, and we 3D printed a box to cover it up, make it look clean. And so this is the top half, and then the bottom half is obviously the LEDs that are all wired up, going upward. We 3D printed a coupler, a motor, a base, and then we have our driver here where we control how much power we give to the motor. And because we have a spherical design, we needed to look into where to display, where is the most optimal to display. So we found that between 45 degrees up and below the latitude line, so from the middle, you get the best display because the circumference is closest to the equator. So this area is the best to display, and then near the poles it gets distorted, so we shouldn't display there. And this is how we set the resolution. So we wanted this to basically act as a monitor. So because there's 72 pixels vertically, we also decided to do 72 pixels horizontally, which makes a square if it's one side, or if it's both sides, it's 272 by 72 squared. So where we can display those images.
So I'll talk a little bit about how we are processing this data. So we did say that we upgraded the LEDs here, so it's using SPI protocol. One bottleneck we found is that the SPI is running at 8 megahertz, and ideally we would like this to be faster. We stuck with the Arduino Nano design, but if we upgrade the hardware, we can display things better, but we tried to see what we can get done with an Arduino. So for this design, I created an image processing sequence where you can upload raster images or make your own image by clicking. You can just kind of display it, and some basic image processing to rescale it to our dimensions. So as Nubar explained, it'll be 144 by 72 because it's a sphere, and it'll generate a library, an array that we're feeding into the Arduino, and we stream the data. And the effect that we were aiming for is not a static image, not a long exposure, but more of an animation. That's why we kind of chose an image of a globe and the Death Star, so that we wanted an effect where the Death Star is kind of rotating and we see the globe rotating as well. So we'll do a quick demonstration of 3 things. One is using the Hall effect sensor where we can get a long exposure shot, which we've done previously. So we just wanted to showcase that we can display a static text in the same location using the Hall effect, and then display animations with the Death Star and image of Copia. Perfect.
Can we maybe get the lights?
Yeah, you want to turn off the lights?
Yeah, please.
You guys want to turn off the lights for a second?
I tasted it. Where's Earth? Oh. So
Now, if you're done with the TV.
So this is Earth?
Let's kill the TV.
Sure. It's meant to be globe or Earth. It's a spinning globe, so it's not always in the same position, but you can make out the continents. You can see Europe, Africa, North America, South America. So this is the first design we talked about.
In a second, what I'll do is I'll get a couple of still pictures. I'll make a GIF animation because that'll show up better, I think.
Yeah, that is
When,
so
when,
fast.
when you're ready, if you guys
We're gonna
want to,
change, but we'll wait for it.
when you're ready, if you guys want to all stand, the three of you in a row, what I'll do is I'll get a